Hello, grade 11s. In today's lesson, we're going to be looking at trigonometry, and we are looking at solving trigonometry with the aid of a diagram. So I'll specifically be dealing with those questions that say without the use of a calculator and only use the aid of a diagram, calculate the values of. So now, before we start with the lesson, please like, subscribe to the channel so that you get more of this content, and please comment and share the videos, and let me know on the comment section, guys, if the lessons are any help to you. Without any further ado, let's just get right down to the lesson. So we have question 5. It says in the diagram below, P K is where it has the coordinates K to 24. It's a point in the second quadrant such that OP is 25 units. N is a point on the positive x-axis, and PON is theta, right? As we can see, our PON here, PON is theta, right? Now with these questions, the first thing that you want to do before you even look at the question, you will look at the diagram, interact with your diagram, and see that here, in order to solve these questions, we need two concepts, right? So which is your SOHCAHTOA. So here you need to use your concept of SOHCAHTOA, which are your trig ratios. We already done that. Your sine is opposite of a hypotenuse, cos is adjacent of a hypotenuse, and tan is opposite of adjacent. And then also another thing you'll be using is your Pythagoras theorem, right? So these two concepts, we know that they're only applicable to right angles, triangle, right? So now, in order to make sure that we use these two concepts, we have to now extend here the graph, or join a vertical line to that diagonal line so that it becomes a right angle triangle. So this is the first thing that you want to do. You want to make that diagonal line, you want to join a vertical line to that diagonal line so that this becomes a right angle triangle, so that these two concepts can now apply. Now that you have a right angle triangle, now you will always see that they will give you two sides, two known sides, right? But then one will be missing. So in this case, we can see we are given in a form of coordinates. K is 224, but we know our coordinates always come in the form of x is to y. So this K here, it's supposed to be on the x-axis, and this 24 here, it's supposed to be on this vertical line going vertically along the y-axis, right? Along with the y-axis. Then we have our 24. Always here, the first step would be to calculate this missing side. So most of the time, you'll find that the first question requires you to calculate that that value there. But then sometimes you don't find it, you don't find that question, you will need to calculate it even though they do not ask it. So always make it a point that the first step here is you calculating the missing side. So after you have joined that vertical line to form the right angle triangle, and then you have placed all your values in the correct positions, make sure you calculate the missing side. Now to calculate the missing side, obviously you will have to use your Pythagoras theorem, because note, you do not have any angles here. You do not have any angles, but then you do have two known sides. So you can use your Pythagoras theorem, which goes r squared is equals to x squared plus y squared. Now your r is the hypotenuse, right? So we can just substitute to have 25 square is equals to our x here, in this case is k. Then we have our k and then square. Then what is our y? That's 24. Then it's just a matter of doing your maths here. 25 squared minus 24 squared, if you transpose it, now you have k squared is equals to 49, right? Now that 49, remember you are looking for k, not k squared, so you can square both sides. Now you have k is equals to plus or minus 7. Now we know when a number comes off from a square root, it becomes a plus or minus. Now it's up to us to decide according to our Cartesian plane. Since they said this is in the second quadrant, we know our x values in the second quadrant are negative, right? Because remember, they are on the left of the Cartesian plane. So that means our k is equals to -7. Now, as soon as you have calculated that, you want to plug in your value here. So you have -7 there, right? So now you have calculated for the value of k, 2 marks, right? You have calculated for that. So now we are looking for tan theta. So to calculate for tan theta, let's go. Now that we have all that, our diagram now has all those values. So let's draw the diagram. Remember, we had 25 and then we had 24 this side and then our -7 here. So now to calculate for 5.1.2 our tan theta, it's now simple. Remember, we now use our SOHCAHTOA since now we have all the sides, right? All 3 sides are given. So now we can say tan is opposite of adjacent. What is our opposite? Remember, our reference angle becomes this one here, right? So here, remember, we had that 180 minus theta because that whole angle from here to there was theta, right? So now having that, we have tan theta will now become opposite. What is our opposite? The opposite to this angle is 24. And the adjacent to that angle is -7. So for 1 mark, you have that tan theta is equal to 24 over -7. Then for 5.1.3, what do we have? It says calculate or determine the value of sine theta if theta plus alpha, or determine the value of sine alpha. I meant to say if theta plus alpha is equal to 360 degrees. Now let's see what is happening here. Remember, in our diagram we have theta, but then here we are told of alpha, right? So we must find a way to write this alpha in terms of theta, because in the diagram here we are dealing with theta. How can we write this alpha in terms of theta? So we can just make this alpha the subject of the formula, right? So for this one, we'll go 5.1.3. We have alpha plus theta is equal to 360 degrees. Now we want to write alpha in terms of theta. So we have 360 degrees minus theta, right? So okay, now having that, we can now go and say this will be, so if we plug in our trig ratio sine, because we are looking for sine theta, now we'll have sine theta is equal to sine, so we introduce the trig ratio sine on both sides, right? 360 minus theta. Now we know that sine 360 minus theta represents sine in the 4th quadrant. So if you can still remember our notes, we said how is sine in the 4th quadrant. So if you still remember your cast diagram, we know that sine in the 4th quadrant is negative. So here we have negative sine theta. So in other words, our sine alpha is equal to negative sine theta. So having to calculate sine alpha would be the same as calculating for negative sine theta. So because here we are dealing with theta, we can say what is sine? Sine is opposite over hypotenuse. So what is opposite of this angle? What is opposite of this angle is the 24, but remember we have a negative outside, so I factored it out, and then over the hypotenuse, which is 25, right? So that means for our sine alpha, what do we have? Our sine alpha is equal to negative 24 over 25, right? So that's it, negative 24 over 25. Okay, so 5.1.4 says now determine the value of cos squared theta minus sine squared alpha, right? So now to calculate that one, remember what do we have here? So we have this, our 24, our -7, right? So we already have this one filled out, right? So we can just be looking for cos theta here according to what we have. So this is our cos theta will now become, remember SOHCAHTOA, we have what? Adjacent over hypotenuse, right? So what is adjacent to this angle here? Adjacent is -7 and our hypotenuse is 25, right? But then remember we have calculated sine alpha in the previous question, and then we got that sine alpha is equals to -24 over 25. Now it's just a matter of substituting here. So let's do it. So we have our cos squared theta minus sine squared alpha. So for our cos, we have -7 over 25. But remember they said square, so we need to square that value. Minus, we have here -24 over 25. And then we also square that value, right? So now having to punch that in your calculator. -527 over 625, right? And that's how you have it. Awesome. Okay, so we have another question here. It says in the diagram below, P having the coordinates -16 is to Y is a point such that OP is 20 units. So we are given here OP is 20 units, so let's fill it in. Our OP is 20 units, and then the reflex ROP, the reflex is theta as indicated there. And then we are given our coordinates -16 is to Y, but we know the coordinates are in the form of what X is to Y, right? So this -16 belongs where? Belongs here, right? In the x-axis, and then this y will be here going vertically along with the y-axis, right? Now 3.1.1 says calculate the value of y. As I have indicated in the previous question, you will always have to calculate that missing side. Now how do we calculate that missing side? We calculate it using Pythagoras theorem. So for 3.1.1 we have r squared is equals to x squared plus y squared, right? And then what is our r? Our r, remember, is the Pythagoras. So we have, is the hypotenuse. So we have our 20 square is equals to x is -16 square plus y square. Now having to calculate this, your 20 square, and then transpose this 16 square, it will give you 144, and then y squared. Now we know what to do. We are not looking for y squared, we are looking for y, so we square both sides. Square both sides, then our y will be plus or minus 12, right? Now at this point we have to decide whether our y is positive or negative. But then looking at where our y is, it is below the x-axis, and we know our y values below the x-axis are always negative. Therefore our y is equals to -12, right? So that's it. Now 3.1.2 says determine the value of each of the following without using a calculator, right? So with the aid of a diagram, if they say without using a calculator, that means with the aid of the diagram that we have there. So for A we are given cos. Let's calculate A. We are given is it called or sine? We are given sine 180 minus theta, right? But then remember we need to first interpret this, right? Our sine 180 minus theta indicates what? The second quadrant. Now we are only looking for things that will say theta, right? We are looking for our trig ratio to say theta only. Now how is sine in the second quadrant? Sine in the second quadrant, we know it is positive using our cast diagram, right? So you can see this is the second quadrant and sine there is positive. So now we have sine theta, we can now use our diagram. Remember, now in our diagram, what do we have here? We have negative 12. So the angle we are looking for here is this one, right? So our angle must always be between the x-axis and the hypotenuse side. So that's the angle we are looking for. So the opposite here, because SOHCAHTOA sine is opposite of a hypotenuse, the opposite is negative 12 and the hypotenuse is 20. So having to write that our value is negative 12 over 20. Now looking at these numbers, we can see that we can still factorize them further, right? By doing what? By looking for that common factor that can go in here, or that common factor that can go into 12 and 20 and leave no remainder. So what is that number? It's 4. 4 goes how many times into negative 12? It goes negative 3 times. And then 4 goes how many times into 20? It goes 5 times. So our answer is negative 3 over 5 simplified, right? Simplified. Then for B we have cos 180 plus theta. Now we know the 180 plus theta indicates what? The third quadrant. So this is the reduction formula for the third quadrant. Now how is cos in the third quadrant? We can see that the only trig ratio that is positive in the third quadrant is tan. So that makes our cos negative. So we have negative cos theta. Now let's go back to our diagram. For our cos, we know cos, applying our SOHCAHTOA, we know cos is adjacent over hypotenuse, right? So what is our adjacent? What is adjacent to this theta here? It's negative 16. And what is a hypotenuse is 20, right? So having that, we have negative outside the bracket here, the negative 16 over 20. Now, is there any number that can go to 16 and 20 and leave no remainder? Let's simplify. So we have 4. 4 goes how many times in here? It goes 4 times. And then 4 goes how many times in here? It goes 5 times. But remember, we have this negative and negative, making this a positive. So we have 4 over 5. And that becomes our solution. Okay, so we have our question 5. It says, do not use a calculator for this question. 5.1 says, given cos theta is equals to negative 1 over 3, and the restriction is your theta must be between the angles 0 to 180 degrees, which we can see this is between the first and the second quadrant. Now they say determine with the aid of a diagram the value of the following, right? So we can see that we do not have the diagram here, meaning it is our duty to draw the diagram, right? Now we are given the option of drawing in the first and the second quadrant. But remember, we cannot draw in both these quadrants. We need to choose one quadrant, whereby we'll need to draw either the first or the second quadrant. But then if we can remember and apply our SOHCAHTOA here, so you have the first option, you can look at SOHCAHTOA and just look at cos here and say cos is adjacent over hypotenuse, which can be written as x over r, right? So that means here the negative 1 represents your x and the 3 represents your r. Why the 3 is positive? Because remember, your hypotenuse is going diagonal and can never be negative. Always your hypotenuse will always be positive, right? Now you can just check this and ask yourself, between the first quadrant and the second quadrant, where do I have my x values being negative? So for that, you have a clear answer. You know, in the second quadrant, that's where your x is negative, right? So that's the first way to go about it. Another way is that you can consider your cast diagram, right? And then using your cast, if you are given the option of the first and the second quadrant, right? and then you are given cos here, you ask yourself, where is cos a negative? Is it in the first quadrant or in the second quadrant? Now, if you come to think about it, we know that all trig ratios in the first quadrant are positive, and in the second quadrant, only sine is positive. So that means cos is negative in the second quadrant. That will give you that we need to draw where? In the second quadrant. That would indicate to you that we need to draw in the second quadrant. Now let's go. Having to draw now, we will do that and draw our right angle triangle in the second quadrant. Then remember, we have cos theta is equals to -1/3. Now we know this -1 goes where? To x, and that 3 goes to r, right? So our x is where? Here. So we have -1 here, we have 3. Once again, we have a missing side, y, right? Now we know the first step is always to calculate that missing side, right? So we have r² is equals to x² plus y², right? Now what is our r? That's 3. So we substitute 3 and then square. And then what is our x? That's -1, and then square that, plus what is our y? That's what we are looking for. So we have y². So 3 squared, that gives us 9, right? And then if you transpose this one here, what do we have? We obviously have 8, right? So this becomes 8 is equals to y². Now remember, we are looking for y, so we're gonna square both sides. So for that, we have remember, without the use of a calculator, so if we break that into SAT form, so we have 4 times 2, which will translate to square root of 4 being 2, and then we'll be left with that square inside there. So that means our y value here is 2√2, right? So awesome. Now let's get to the questions. Remember, having this, we haven't calculated anything, right? So now we go to 5.1.1. It says calculate tan 180 degrees plus theta. So now we are required to calculate tan 180 degrees plus theta. Now we know the 180 degrees plus theta indicates what? It indicates the third quadrant. How is tan in the third quadrant? We have our cast diagram here. So in the third quadrant, we know tan is positive, right? So that means 5.1.1, we have tan 180 degrees plus theta. That will give us tan theta because it's positive there. And then remember, now we have our tan is opposite. So our angle is here, our theta is here. It's opposite over adjacent. So we have 2√2 over -1, which will obviously give us -2√2, right? Awesome. Okay, so we have 5.1.2 here. It says, now with the aid of a diagram, determine the value of this one, right? So we have 3 sine theta minus 90 degrees. So we know once we have something like this, theta minus 90 degrees, this indicates that we are working with a negative angle. Remember, the format we are used to is 90 minus theta, or we have 90 degrees plus theta. So once they start with the with theta here and then say minus, that's a negative angle. But then with this one, they can do it. They can say theta plus 90 degrees. This doesn't indicate a negative angle because remember, you can just swap this around and it will still be the same as that one. So only if you have something like this, theta minus 90 degrees, that's when you say you are working with a negative angle, right? So now, okay, let's check. We do know that negative angle of sine is negative, right? So we have 3 sine and then theta minus 90 degrees. So the first thing we're going to try to do here is present this in a way that we know. Then factor out the negative, we have 90 minus theta. So this is the format we are used to. So now I just factor out this negative so that we see this is a negative angle. So now it becomes clear to see that we are working with a negative angle, right? Now what is sine of a negative angle? We know sine of a negative angle is negative. So we have that negative sine 90 degrees minus theta. Then you close off like that. Now let's see, but we know when we are working with this 90 minus theta, this becomes a cofunction, right? So we know for this one, this is a cofunction and it changes to what? To cos. So whenever you have that 90 degrees minus theta or 90 plus theta for sine and cos, those are cofunctions, right? Now that means what do we have? We have 3, and then this changes to, how is sine in the first quadrant? It is positive. So this will change to cos theta. So remember, this negative here is from here, right? So the negative is from the one that we factored out, but then sine in the first quadrant is positive cos theta. Now it's just a matter of looking at the diagram and find the value for cos theta using the diagram, right? So in the diagram, what do we have? We have remember, we had this in the second quadrant, and then it was 3 here, negative here, and then what did we find here? 2 root 2, right? Then remember, cos is adjacent over hypotenuse, so that means we have 3, and then that's negative. What is our adjacent? Our adjacent is -1, and what is our hypotenuse? Is 3, right? So we do that, and then this becomes negative, and negative is positive, so we have 3 times 1 over 3. Then you can see what will happen here. 3 times 1 over 3, the 3's will cancel out, and then we'll only be left with 1. So that becomes our solution 1.